Air standard assumptions. Now, these are the other assumptions which are applied on the actual processes to simplify them so that they can be analyzed easily. So there are four assumptions. Number one, the working fluid is air, which continuously circulates in a closed loop and always behaves as an ideal gas. So we will always replace the actual gases with air. That will simplify the analysis of the actual process. Number two, all the processes that make up the cycle are internally reversible. So this is the second assumption. We will assume that processes are internally reversible. Number third, the combustion process is replaced by a heat addition process from an external source. So always the combustion process will be replaced by the heat addition process. Okay, so I'm going to explain you this by using the illustration which is given in the on the left side of this these assumptions. Number four, the exhaust process is replaced by a heat rejection process that restores the working fluid to its initial state. So these are the four main assumptions. Number one, we will assume that working fluid is air. Number two, processes are internally reversible. Combustion process will be replaced by heat addition process, and exhaust process will be replaced by heat rejection process. So how we can apply the third assumption on the actual cycle, that is explained here. So here is the actual process. In actual process, there is always air and fuel mixture that goes into the combustion chamber where combustion takes place, and at the end exhaust gases or combustion products are come out from the combustion chamber. Now if we apply the air standard assumptions on this process, so because this is a combustion process, so that will be replaced by heat addition process. Okay, so first of all we will assume that working fluid is air, so air fuel mixture will be replaced by air, and combustion will be replaced by heat addition. Means we will there will be no any combustion chamber, so this will be heating section where Q will be coming into the system, and at the means exit there will be again air. So if the at inlet the temperature of air is low, then at exit, because we have added some heat into the air, so therefore at exit temperature will be high. So this is how we can apply the air standard assumptions on any process. Now there is also another assumption. If we apply that, then these air standard assumptions are known as cold air standard assumptions. So now that assumption is when the working fluid is considered to be air with constant specific heats at room temperature, so at 25 degrees centigrade. So we will, if we consider the value of Cp and Cv constant, then the air standard assumptions will be known as cold air standard assumptions. Okay, so this is the addition. If we add this assumptions also, then air standard assumption will be converted into cold air standard assumptions. Then air standard cycle. So a cycle for which the air standard assumptions are applicable. Okay, so whatever this cycle may be, so if these assumptions are applicable on their cycle, that will be known as air standard cycle.